Good day, everyone. Welcome back to Mathematics MJ, where numbers make sense. So today, guys, I want us to focus on geometric sequence. As we all know that on our previous video, we've already covered the arithmetic sequence. So today we're focusing on geometric sequence. So before we even go further, I want us to break down the general formula of geometric sequence. So the formula is given as Tn is equals to ARn minus 1, right? Maybe you're wondering what is A, what is R, what is N, right? And even Tn. But those who watched the previous video, at this point, they know. Just the only thing which is included here is our R, right? So we don't know our R. So again, so for Tn, we know that this is the nth term. A, that's our first term. Your N, it's the position or the number of term. So it's the position or the number of the term. What else? R, R, the new guy. So we call this guy our common ratio. And there's a formula to actually calculate this guy. So we have to say T2 divided by T1 equals to T3 divided by T2. Remember, when we were busy dealing with the arithmetic sequence, we said for common difference, D is given as T2 minus T1 equals to T3 minus T2, right? So for common ratio, we are dividing. I hope it makes sense. That's the difference between the common ratio and the common difference. So before we even dive deeper into this, I want us to go back to how to express now the geometric terms, right? On our arithmetic sequence, we said T1 is equals to A, T2 is equals to A plus D, T3 is equals to A plus 2D, and then we've noticed that if there's 2 here, then there's 1 there. If there's 3 there, there's 2. Just like that, right? So if there's 1 there, there's 0 here. So that's the sequence we have to use, right? So even if we go to T number 50, eventually we'll have our A plus and then 49D, right? So what happens now when we start to express now our geometric terms? How do we express our geometric terms? Again, we use the general formula Tn is equals to Arn minus 1, right? Now let's try and introduce, or rather let's try and substitute 1 in place of n. Here's my 1 there, equals to, you have your Ar, in place of n, I'm substituting 1 there. That's minus 1, right? So basically T1 is equals to Ar, 1 minus 1 is just a 0, and Ar, any base to the exponent of 0 is equals to 1. So this is just 1. So this basically will give us A. Hence, we are saying T1 is equals to A, right? Now let's move to T2. Let's check T2. For T2, you will have your AR 2 minus 1, right? And then AR 2 minus 1 is just 1. So T2, you just subtract 1. So that's 2. You you subtract 1, and then we get 1 there, right? Same applies. It's the same logic. So even T3, you have your AR 3 minus 1, which will give us AR squared. Now, one would say, okay, but now let's try and express T100. That's not a problem. Let's do that. So T100 would be our AR 99. That's T100. I hope it makes sense. So eventually you have to be able to use these geometric terms when it comes to questions, basically when answering the questions. But as time goes by, you'll be able to use them. And the more I start explaining the examples and everything, that's when now you will get used to using these terms, because there's so many examples which include or involves this part, right? So let's just move to example one. Let's move to example one quickly. So for our example one, okay, let me just write quickly. Example one. And then the sequence, we have your 2, 6, and 18. I know some of you now are shocked that I'm using this beautiful handwriting. I've been practicing, guys. I've been practicing on how to write. Ne? So, example one, find the sixth term of the sequence. And then we are given the sequence 2, 6, and 18, right? So, the first thing is that you have to find is the first term. What is your first term? That's 2, right? Now, get your general, sorry, your common ratio, rather. Sorry about that. We have to look for the common ratio, which is our R. So that's T2 divided by T1. We get 6 over 2, which is equals to 3, right? Same applies to T3 divided by T2. And then we get your 18 over 6, which is equals to 3. So basically, we can conclude and say R is equals to 3. Good. So our R there is equals to 3. Now we can just say R is equals to 3. So now we're looking for T number 6. That's an unknown, right? So let's look for our T number 6 then. So what do? You have your Tn is equals to ARN using the general formula there equals to your A was said that's 2, your R that's 3, N minus 1, right? So this is the general formula. Now substitute. Now in place of N, we substitute 6. So T6 is equals to 2 times 3 and then raised to the power of 6 minus 1, right? And then this gives us 2 times 3 to the power 5. That's T6. So, and what do we get there? So when you use your calculator, you get your 486. Then that's it. So we're done with our example, example 1, right? Now let's move to example 2. Let's move to example 2. So for example 2, okay, example 2. Now they're saying which term? And then here's the sequence: 20 minus 4. 4 is to 5. Is equal to 4 over 125. Okay, we are given a sequence and the nth term there, right? So your A is equals to 20. Let's look for R. Again, T2 divided by T1 equals to T3 divided by T2. And then you'll get your R, right? So what is our T2? That's negative 4 over 20. And what do you get? You get your minus 1 over 5. Same applies to T3 over T2. What do you get? You have your 4 over 5 divided by negative 4. And again, when you use a calculator, you get your minus 1 over 5. So basically our R is equals to minus 1 over 5. So this is your R there, minus 1 over 5. And then your Tn, it's this. So that's 4 over 125. Which term of the sequence? Which term? That's the keyword, which term? Basically, they're looking for n. So n is equals to the question mark. And we're also given the nth term there, which is 4 over 125. So basically here, we just need to use the general formula of Tn equals to AR to the exponent n minus 1. And then in place of Tn, we substitute 4 over 125. In place of A, we substitute 20. And then there's minus 1 over 5 there for R, and then n minus 1. We're looking for n. So from here, we're done now with the sequences. We're done. It's about exponents now. We have to apply the laws of exponents and algebra. So divide both sides there, and then you end up with your 1 over 625 equals to negative 1 over 5 to the power n minus 1, right? Now we're done with all the sequences. We are now focusing on laws of exponents and algebra, right? So, but this can be expressed as, okay, by looking at this, I can see the direction. This is expressed as 1 over 5. So, which means I must fight for getting the bases to be the same and drop down the exponents. What do I mean by that? I have to express this as 5 as well. So this is minus 1 over 5 to the power n minus 1. And then from here, now we can also express this as negative 1 over 5. The direction. Bases should be the same. So this is 1 over 5 and minus 1. We used this law. A over B, n, and n. This can be expressed as A over B all to the power n, right? This is the law that we have used. And then from here, you have the same bases, right? Now drop down the exponents. So meaning 4 is equals to n minus 1. And then n is equals to 5. Then we can say therefore t number 5 is equals to 400, 4 over 125. Then we're done with this example. Now we can move to example 3. We can just move to example 3. Let's move to example 3. So for example 3, we're given that, okay, they're saying determine the geometric 16 is 1 over 729. Okay, so for this kind of a question, we have to use the geometric terms, how to express them first, right? So T2, we have to create the equation. Second term is equal to 1 over 9. So meaning T2 is equal to 1 over 9. And then the sixth term is equal to 1 over 729. So T6 is equals to 1 over 729. And then from here, we use how to express the terms of geometric sequence. So T2, that's A r to the power 1 equals to 1 over 9. T6 AR to the power 5 equals to 1 over 729. And then from here, now we have created equation 1 and equation 2. We're done with sequences now. We have to focus on simultaneous equation, right? So equation 2 divided by equation 1. Equation 2, that's a to the power, okay, AR to the power 5 equals to 1 over 729, then divide by AR to the power 1, here divided by 1 over 9, right? And then from here, these two, they cancel. When you divide the same bases, you subtract the exponents. So 5 minus 1, that's 4. So this is r to the power 4 equals to, now we divide these two. You can just use your calculator and you will end up getting your 1 over 81, right? And then from here, again, you can use your calculator or you can change this into r to the power 4, which is equal to 1 over 3 to the power of 4. And then you have your r to the power 4 equals to your 1 over 3 to the power 4. And then you drop down the bases now. So you'll have your r is equals to, because this is an even number, then we introduce plus or minus, right? So now you have your plus or minus 1 over 3, right? And then when you're done, now, which means your r is equals to 1 over 3 as well as your negative 1 over 3. And then take that equation 3, which is our r, substitute it back to equation 1. So equation 1, we have your AR equals to 1 over 3, because this one is just this simple one, right? So you'll have your A there. Let's start with 1 over 3. If r is equals to 1 over 3 there, we divide both sides by 1 over 3. 1 over 3. I don't want to say anything anymore with these numbers. I'll just write. So we have your 1 over 3, divide both sides there. Then your a is equals to 1 over 3. Your a is equals to 1 over 3. Perfect. Now let's move to the next one. Again, we're still using the same equation. AR equals to 1 over 9, but then now we substitute R as 1 over negative 3. And then we divide both sides there by negative 1 over 3. And then you get your A as negative 1 over 3. Now that you got your A there, they said, okay, the question is about finding the geometric sequence. So we are looking for the pattern. So after getting your A is the first term, right? You get your first term and then multiply your first term with your R to get the next term. So 1 over 3 times 1 over 3, that's 1 over 9. And then multiply it by 1 over 3 again, that's 1 over 27. And then this is your pattern. If R is 1 over 3 and A is 1 over 3. And then for this one, you have your negative 1 over 3, multiply it with negative 1 over 3 because your R is negative 1 over 3, and you will get your positive 1 over 9. And then you multiply again with your R. 1 over 9 times negative 1 over 3, you will get your negative 1 over 27. And then this is your pattern. Then you've answered the question. So you have two patterns. That's the first one and the second one. So basically here, you were supposed to calculate for A and R so that you can get these two patterns, right? I hope it makes sense. This was example 3. Let's move to example 4, which is our last example. So for example 4, okay, we are given that T4 is x minus 4. T5 is x plus 2. And T6 is 3x plus 1. Determine so for A, we are looking for x. We have to solve for x. And then for B, we have to also find the sequence. No problem. So now let's start. So here, our terms are in the form of variables. What do I mean by saying variables? Variables are alphabets. You have your x, you have your y, all of that. So when we are given a pattern with variables, what do? You use the law T2 divided by T1 equals to T3 divided by T2. But in this case, we have to use T5, right? We have to use T5 divided by T4. And then T6 divided by T5 because we're given T4, T5, and T6. And then from there, what is our T5? T5 is x plus 2. So you have your x plus 2 there divided by T4, that's x minus 4. equals to, what is our T6? 3x plus 1 divided by T5, that's x plus 2. Now, for your information, you're done with patterns now. You're left with fractions and equations. How do you take care of such? Here you just cross multiply, right? So x plus 2 times x plus 2. We're cross multiplying here. And then you have your x minus 4 multiplied by 3x plus 1, right? Now let's use the FOIL method. When you use your FOIL method, you will get your x squared plus 4x plus 4 equals to, and then on the other hand, we have your 3x squared there minus 11x minus 4. We still use the FOIL method here, right? And then from here, now we start by collecting the items, add them together, or even subtract them together, right? And then by doing that, we end up at this step. X minus 3, which is 1 minus 3, that's negative 2, x squared, right? 4 plus 11, that's positive 15, x. And then 4 plus 4, that's positive 8, equals to 0. Nice. And then divide everything by negative. When we divide everything by negative, the sign changes. So the sign, what? They change. So you'll end up with your 2x squared minus 15x minus 8 equals to 0. And then from here, factorize, but now if the coefficient of x squared is more than 1, then we use the cross method. You look for the factors of this first, which is 2. Factors of 2, you have your 2 and 1, and then you also look for the factors of negative 8. So you will have your negative 8 and 1, right? Perfect. And then this will be our positive there. Now cross multiply. The aim is to get the middle term, right? Now cross multiply. We have to cross multiply there. And when we cross multiply 2 times negative 8, we get negative 16, right? And then 1 times 1, we get positive 1. Okay, now subtract 1 minus 16, we get minus 15, which is the middle term, which means the factors are correct, right? We've factorized correctly. So which means now this becomes the first bracket, this becomes the second bracket. Your job is to introduce x there. That's it. So first bracket, second bracket. Just copy and paste there. So you'll have your 2x plus 1 as well as x minus 8 equals to 0. As from here, your x should be equals to negative half, or your x should be equals to 8. And then from here, we're done solving for x. We're done. We've answered the question. So now we have to get the sequence, which is b. So for b, we have to get the sequence. So we must get the sequence. So our b, we're looking for the sequence, but we know very well that x is equals to negative 1 over 2, or x is equals to 8. Now that we know that, T5 is equals to, what is our T5? T5 is equals to x plus 2. Oh, we have to start with T4. T4 is equals to x minus 4. Now, in place of x, we substitute minus half. Minus 4. And what do we get? So when we substitute there, we get minus 9 over 2. And then for T5, we substitute again. So our T5, that's x plus 2. So that's x plus 2. Substitute minus half again, plus 2. And then we get 3 over 2. And then T6, which is the last one. T number 6. That's 3. I think it's 3x plus 1. Yes, 3x plus 1. Again, substitute the negative half. And what do you get there? When you substitute your negative half, you get your minus, half, right? So T6, that's minus half. So basically this becomes negative 9 over 2 is to 3 over 2 is to negative half. And then we have to look for R now. Now we have to look for R. So 3 over 2 divided by negative 9 over 2, we get negative 1 over 3. Same applies to negative half divided by 3 over 2, we get negative 1 over 3. And then from here, let's use T number 6, right? Let's use T number 6. So T number 6 is equals to negative, T number 6 is equals to negative half. T number 6 is equals to negative half, right? Perfect. But let's use this and express T6 as AR to the power 5 equals to negative 1 over 2. But what is our R? R is negative 1 over 3. So you have your A there, and then negative 1 over 3 to the power 5 equals to negative 1 over 2. And then divide both sides by negative 1 over 3. To the power 5. Same applies here. And then they cancel these two. Then your A is equals to 243 over 2. Now, after getting the value of A, you just multiply the value of A with your R to get the following terms, just like that. So we multiply by negative 1 over 3, we get negative 81 over 2. Multiply again, we get 27 over 2. Then that's it for the sequence, right? But only if x is equals to negative half. So what happens now if x is equals to 8? So now x is equals to 8. Again, we do the same thing. So for T4, when you substitute your 8 in place of x, you will get T4 as 4. And then for T5, you substitute again, we get 10. And then for T6, you substitute, you get your 25. And then from here, now we have your 4 is to 10 is to 25. Look for R, we divide, right? So we have to divide there and you get your 5/2, your 5/2, right? Now, after getting your R again, we go back to T number 6, which is equals to 25. But T6, that's a R to the power 5 equals to 25. And then in place of R, we substitute 5/2 to the power 5 equals to 25. Divide both sides by 5/2 to the power 5. And then you use your calculator there to get your A as 32 over 125. And then from here, you just multiply your A with your R. What is your R? We said R is 5/2. So multiply this term with 5/2. When you multiply it, we get 16/25. Multiply this term with R again, you get your 8/5. And then you have your pattern again. Then we're done. For today's lesson, we are done. Thank you so much, guys, for your time, for watching my videos, and I hope they are of good help. Don't forget to subscribe, like, and also share my videos. Bye.